Now going to question number 10. Here we have a data question, also known as command of evidence. And for these, you want to start with the prompt, then make sense of the text in your own words, then determine on your own how the data might illustrate the point the text is making. Finally, look at the answer choices. So let's go through that process. So we're going to start with the prompt, which is this part right here, and it's asking for data that supports the suggestion. So to continue, we need to know what the suggestion is. So let's look through the text. The largest of these dinosaurs, the family of carnivorous dinosaurs, that includes these, and including also T-Rex, are thought to have had the strongest bites of any land animals in Earth's history. Determining the bite force of extinct animals can be difficult, however, and paleontologists have suggested that an estimate of dinosaur bite force may be significantly influenced by the methodology used in generating that estimate. By the way, the SAT loves the word methodology, which is the process that you go through when doing an experiment or a study. But the claim is that the estimate of dinosaur bite force is influenced by the methodology. In other words, it's not a perfect estimate. If you use one methodology, you may get a higher value, and another one, you may get a lower value. So let's verify that in the data now on our own before we look at the answers. That's very important. And the methods are modeling, tooth analysis, body mass scaling, and these two kind of have the same method. So the ones that have the same method seem to also have similar measurements, 35,000 to around 60,000. And the two that have other methods also seem to have totally other measurements. So the data definitely seems to support the idea that the method you use to measure has a heavy effect on the results that you're going to get. And let's start looking at the answers. A says the study by Mears, this one, used body mass scaling, correct, and produced the lowest estimate, not correct. That's actually the highest estimate. So we found one thing that we can use to get rid of answer choice A there. Okay, and now going over to choice B, in their study, these guys use tooth bone analysis to produce an estimated bite force range with a minimum of 8,000 and a max of 34,000. So that's all accurate according to the graph, but it doesn't prove the point that the estimate of dinosaur bite force is influenced by what method you used. So it doesn't really seem to back anything up, even though it's not factually wrong like A was. C, the bite force estimates produced by Bates and Falkingham, which is this one, and Cost et al., which is that one, were similar to each other, while the estimates produced by the other two guys differed substantially. So that seems to back up the point. The method you're using influences the numbers you get. So we like this one. And last but not least, D says, the estimated maximum bite force produced by, well, let's erase this real quick, by Cost et al. Exceeded the one by Bates and Falkingham, even though both groups used the same method. I don't know if I'd say that the estimate exceeded because they had overlapping ranges. So if I were going to say that one exceeded the other, I might say it more specifically because one of them's from 35,000 to 63, the other one's from 35 to 57. So I don't know if one necessarily exceeds the other. They're almost like 90% the same or 95% the same, except for that little bit between 57 and 63. So I don't think that that's really the way you should say that. And that gets rid of answer choice D, and the one remaining is C.